Well, this is a interesting integral. If you take a look at the denominator, you could actually factor. So we'd have 11 times 1. We would need 1 positive and 1 negative. X times x. And this negative x times this 11 would be negative 11x. This one times the 1 is a positive 1x. That leaves behind negative 10x. The only problem is, the only reason I would be factoring is if I want to do integration by parts. So they sort of threw in a decoy here by making it factorable, yet we cannot use integration by parts because it's got a square root. So that's out. If we tried u substitution, that wouldn't work because we would need a negative 2x minus 10 showing up in the numerator. It's not even close to that. This is not of the form something squared minus something squared, but we could get it to look like that with a little bit of work. So for this right here, I'm going to complete the square. The first thing I'll do is factor out a negative. So I'm dealing with just x squared, and then the 10 would become a positive 10x. The 11 is not allowing us to make a perfect square, so what I'm going to do is move it over by a little bit. And don't forget that I factored out a negative, so this needs to be negative 11. Then, for complete the square, you take the b term, cut it in half, and square it. So if you cut it in half, it's a 5. Square it, it's a 25. So we need to add 25 in and subtract 25 right back out. Or in other words, these two are going to be combined to make a negative 36, and these are going to be factored into a perfect square. So then we've got the negative applying to everything. This we need to factor as x plus 5 squared. Combine these two as negative 36. Alright, now take all of that and put it back in the integral. You know what? I think I'll go ahead and distribute the negative first. So actually it's going to be 36 minus the perfect square. Okay, now go back to the integral. So the 3 constant, just factor it out. Then we'd have 1 over, in the radical, we've got this 36 minus x plus 5 squared. And then at this point you should recognize, well, if this would have been a 1, or in other words, if we had integral of 1 over the square root of 1 minus that right there is sine inverse. So this is going to end up to be sine inverse, but we need to change the 36 into a 1. So we need to factor it. And if you look back to problem number 7 in this series, I did one similar. So I need to factor a 36 out of this. So I'm still working inside of the square root, and then factor. So divide a 36 out of this, divide this by 36 as well. So we'd have 1 minus x plus 5 squared over 36. And we've almost got this looking like this, but this says that u needs to be squared. So this needs to be one big fraction that's squared. So if I rewrite it as x plus 5 over 6 and then square the whole thing, then it will look like this. Also, this can be factored out. So the square root of 36 is a 6 in the denominator. Move that 6 in the denominator out here, so it's going to be 3 over 6. So there's the 3 over 6. And then we've got the square root of 1 minus, and then make it one big fraction that's being squared, x plus 5 over 6 dx. And now it's all ready for sine inverse. So it's going to be 1/2 sine inverse of that fraction, x plus 5 over 6. So whatever u was right here, that's what goes right here. We need plus c, and then there's one small thing missing, which is the chain rule. The derivative of the inside would be a 1/6. Consequently, we need to divide by 1/6. Now we need to clean up these fractions, so multiply by 6 and multiply by 6. On the numerator denominator, we would have, this would be 6 over 2, so that's a 3. Sine inverse of the fraction plus the c, and I'm liking it.